For today, what we're doing is working with chords and arcs. And really, there's three relationships among these that we're going to be doing. And then we'll see a couple different applications of it. So for example, in the event that we're looking at chords running across a circle, what we'll find is that those two chords are going to be congruent if the corresponding arcs are congruent. In other words, we can say that AB as a segment is congruent to CD as a segment if and only if, right, a biconditional, the arc from A to B is also congruent to the arc from C to D. Unless those are the same distance on this same circle, the chords connecting them can't possibly be the same. We are also going to discover that if this part, in other words, a portion of the radius that goes from the center through the chord and is perpendicular, which tells us it's the distance, is the same as the distance here from the center to this chord, then we know those chords will have to be the same. And I've got a visual that, like, if this were a circle and I put a stick in here that was some length, this stick would naturally fall to the bottom of the circle, right? It would just kind of rest along the bottom here. And if I put another circle in the same size, it would rest right on top of that. In other words, they would have to be the same distance away. And if I like stuck that one and then spun it around, wherever it lands, it would be the same distance if they're the same size chord. So this one says that they are equidistant. From the center. In other words, what we're saying is that AB will be congruent to CD if and only if the distance from E to F is the same as the distance from E to G. If they are the same distance, then those chords will be the same size. And if the chords are the same size, then these distances will be the same. Any questions on those first two? Hold on, somebody's asking for the notes link. You guys know they're in Canvas, right? Okay, if I were to take a radius and I run it through this chord so that it makes a right angle, it'll specifically slice this chord in half. And we could prove that if we wanted to by drawing in a radius here and a radius here, and we could then see that because this is shared reflexive and the radius is the same, and these both have right angles, that now we've got an RHL to show that by CP, CTC, they're the same. So if the radius is perpendicular to a chord, then it does a couple things. It bisects the chord, and it also is going to bisect the arc, such that if we know that EH is perpendicular to AB, then we can surmise that EAF and FB are going to be the same size, and that AH and HB will be the same size. Now, I want to talk a little bit about notation here. What's unclear about what I've written here? Is this a segment or is this an arc? Well, I was talking about the arc, not the segment connecting, not the chord. So I need to add on the arc symbol on top. And just like when we talk about segments, we can either say the segment on top means congruent, or we can say without the segment on top, their lengths are equal. We can put the segment on top and say they're congruent, but if we want to say that they have equal measure, we have to put a little m in front of them and say that the measure, in other words, the degree of that arc is the same. Okay, so these are our three theorems that we're going to be using today. Some of them are very straightforward and we'll find a solution simply. Others are going to require a little bit more in depth. So we look at this picture and we see that these chords are shown to be congruent. Of course, those are congruence marks. And if the chords are congruent, we can then surmise that the arcs must be congruent. So this arc and this arc must be the same. If they're the same, we can set them equal to each other. Subtract 24, we get 7x equals 91. 70 is 10 and 21 more is 3, so x equals 13 by dividing by 7. Easy peasy, right? This one you'll find virtually the same. This one you'll find virtually the same. It might be a case where they give you the arc is the same and you have to say that the chords are the same, but it's still going to be a very straightforward algebraic solving. Those will be part of your homework. Number 5 is a little different. How is 5 different? It's still telling us that the chords are the same, which lets us reason that then these arcs should be the same. But I have no information about this arc. Any ideas?
Maybe you could subtract 70 since, never mind. I thought it was a semicircle, but I realized it wasn't.
No, but I like your idea, right? The 76 isn't part of it. So instead of this whole thing adding up to 360, we know that if I take away 76, what remains is going to be even. So one way to do this would be to just represent this as the same algebraic expression. And notice that because these meet in a point here, there's no additional arc here. It's a 0. So 76 plus 6x minus 20 plus another 6x minus 20 makes the whole thing, or 360. So 76 plus 2 times 6x minus 20 equals 360. Take away the 76 and I get 2 times 6x minus 20 equals 284. And then I'll distribute 12x minus 40 equals 284. Add 40, so I get 12x equals 324. That's going to be 2 and 25, so x equals 27. Any questions on that one? Little trickier. And again, we're at the end of the year, right? We've got this unit and then one more unit. So you can expect that they're going to be asking you questions that ask you to understand things from earlier units. So for example, here, what are they asking us about? MP and PN. Okay, those are both parts of radiuses. They're not the whole radii, or not the whole radius. But since they're perpendicular, I know they split these in half. That doesn't really help me. But since these arcs are marked as congruent, I know that these must be equidistant. That means that these two have to be the same. So this one's a very straightforward one, and you could probably just look at the equations and set them equal. That would be not a very reasoned way to do it, but it would have worked in this case. And then if we get that x is 10, we can say that MP is going to be 5 times that 10 minus 34. 50 minus 34 is 16. And again, I'll leave these other 3 questions for you as your homework. Move on to page 2. These are a little bit harder. They take a little more thought. 7 and 8 are exactly like the ones we just did. No reason to put time into those. What about 9? Let's take a look at number 9 here. They tell us that RS is 18, and there's no symbol over it. So that tells me that I have to go the straightest route. In other words, that I'm talking about the chord. Pardon me.
Yes, sir.
Thank you. So if that's 18, what do I see as congruent here? Well, this segment here is 18. Nope, the segment is congruent to this segment, which means that the blue chord is equidistant from the center as this pink chord is. If they're equidistant, then they're the same. So if RS is 18, then TU is 18 as well. And let's see, we're looking for TV. That's only part of that. But it's a right angle. So if the radius comes in and makes a right angle, it cuts this exactly in half. So if 18 is the whole length, TV is equal to half of that, or 9. And so is WS, right? That's half of the RS. All right, so that's easy enough. Now we're talking about some arcs, though. Let's see what we get there. Why you? Why not me? Well, if YU is what we're looking for, we can see that it's going to be half of this whole arc. What did they give us? They gave us that TY is 42. So YU should also be 42 because that's going to be bisected since it's perpendicular. So YU is 42. And now we're looking for the measure of RS. That's the whole arc. Well, if these chords are the same, then the arcs are the same. So that would make these parts 42 as well, which means RS is 84. Would you please take that same idea and try to solve number 10 now? Go. Let's take a look here. Some of them are pretty straightforward. Like if you know BG is 17, then you know that BC, which continues through, that's just going to be twice that. So 17 times 2 is 34. And if we know that this distance is the same as this distance, then BC and BA are the same, which means that BG and GC are the same, and BF and FA are the same as those other two. So FB is going to be half of those chords, which make them 17 as well. But now we're looking at arcs. AB, okay, so that's this whole arc over here. I know that's the same as BC, but I don't have that one either. All they give me is CHA, 3 letters. That means they're giving me a major arc. CHA. So that part's 256. And I know that this whole thing plus these two makes the full circle. So that means 360. So 256 plus the measure of BC plus the measure of BA equals 360. And these two are the same. So I'm going to call it 2 times the measure of AB. Subtracting that is going to give me 56. So 104. Dividing by 2, I get that the measure of AB is 52. Because all this has to add up to 360. That's 52, and so is that. And then EC. Well, since this is perpendicular and it's coming out of the center, that's going to slice this chord in half as well as this arc. So that'll be half of 52, which is 26 degrees. What do you think about this stuff? 5, I can do these easily. It's just intuitive. 3, I need to look at the formulas because they're not really clear in my head yet, but I think I can do this stuff. It seems pretty straightforward. 1, I'm really struggling with this stuff. Okay, good. We'll find in circles, there's a lot of formulas, and in a couple of days, I'll give you a single sheet that helps you manage all of them. But for now, keep doing what we're doing with these notes. The last ones I want to look at are 13 and 14 down here, because these are a little bit different. So it still gives me a circle. This time it doesn't give me anything that's congruent. So it's not like a pair of 2 chords or a pair of 2 arcs that I'm comparing. Instead, what it's showing me is that this radius, XY, is perpendicular. And we know that that slices this chord in half. So since we're looking for the whole chord length, I just need to find half of it and double it. And I can see that this leg is the missing leg in a right triangle, because they've now drawn a radius over this way as well. So what I'm going to do is effectively treat this like last unit. I've got a right triangle. X is up here, 5, 13, and what I'm looking for is, I'll call it side A. How do we find that missing side in a right triangle?
Pythagorean theorem.
Good. So 5 squared plus A squared equals 13 squared. And some of you might even know this from the Pythagorean triples, because this is one of our Pythagorean triples. So A squared equals 144, so A equals 12. And if that part's 12, then the whole length of VW would equal 2 times 12, which is 24. Now, this one's asking about the arc measure. So we're looking for the measure of YW. It's an arc. What information do we need to be able to find the measure of that? Again, they're not going to give us like two congruent corresponding arcs and make them set equal to each other algebraically, because there's only this one. So they're asking you to go back to what you knew from last chapter, right before the weekend. This central angle is going to have the same measure as this arc. So can we find this angle here? If this is the angle I'm looking at, is the 5 opposite, adjacent, or hypotenuse? And is the 13 opposite, adjacent, or hypotenuse? This calls for so, ka, or toa. This is a ka, which means I'll say that the cosine of, we'll call it angle x, equals 5 over 13. And I want to solve for x. Right now it's being cosigned, so I'm going to uncosine both sides. I'm going to get x is equal to the inverse cosine of 5/13. And if I just plug that into my calculator, I'm going to get that x is equal to 67.38 degrees. And since that central angle is that measure, I can surmise that the arc that meets it is also that measure. So the measure of YW is equal to 67.38. And again, they're asking you to go back and recognize your trig knowledge embedded in these problems. That's going to be very true for this circles unit, as well as the last unit on surface area and volume. Okay, folks, this is really it. There's, what, 7 problems I've left for you or something? 8, 9 maybe. You may either choose to spend the next 5 minutes doing those here in class, where you can ask me questions if you have them, or if you'd like, you can take these 5 minutes offline and do them offline if your Wi-Fi is being spotty or you want to get your lunch going because you're starved. We're all done here for the day, and I look forward to seeing you in class tomorrow. Have a good day.
Thank
Thank
you.
you.
Have a good
Thank
day.
you.